Okay, this is an example of a running example. Basically, जो आप लोगों का CP है, इंशाल्लाह you will be having something like this. और as a first task, आपको मैंने अभी जो काम दिया है वो है implementing this tank for example. Okay, so जो example आप लोगों को मैंने दी थी उसके अंदर you are actually working on this process. So once you are done with this process, उसके बाद we will add on the additional thing, for example feedback or feed forward. So here you can see a switch जिससे आप no feed forward or feed forward में with a single switch you can turn your system to include the feed forward control. और अगर आप इसको क्लिक करेंगे तो बैकग्राउंड में you will have only a feedback system. So feedback system and feed forward. Further, what we have here is sort of, so this is a kind of a demonstration. अच्छा, feedback और feed forward में क्या है कि when we are having only the feedback system, तो feedback system में कोई measurement नहीं आ रही होगी. So this disturbance, if you see, it is here. If I increase it from 2 to 3 on this right side, ये जो F out है, pump जो लगा हुआ है, ये disturbance है, ठीक है? This is not in our control right now. कोई feedback, feed forward नहीं है, तो इसका मतलब है कि this signal is not going back. अब मैं इसको अगर 3 कर देता हूँ तो you can see कि the variation, there is a variation in the this height, और उसके बाद वो variation जो है वो let me pause it for a second. So what we have observed here is कि ये जो इसकी height है, इस height के अंदर we have a variation right now. जब आपने इसको disturb किया तो इस disturbance की वजह से, disturbance is this F out. F out जो है ये disturbance है. तो जब आपका 2 से 3 तक disturbance गई है, then in that case what happens कि जो height है उसमें कुछ changes आएंगे, right? Now you will observe, मैं कंटिन्यू करता हूँ और इसको मैं feed forward पे ले जाता हूँ. So let's say for feed forward we have a new stable point. Let me bring it back to 2. Okay, so 0.7 के ऊपर है. अब मैं 0.7 पे रहते हुए अगर इसको दोबारा से डिस्टर्बेंस करता हूँ 3. So what you have observed is, pause for a second. आपने देखा कि ये डिस्टर्बेंस जब हमारे पास हुई है, let me make it like कितना है, 12,000 है, तो make it 8,000. 8,000. Okay, again here also, but 8 need 13. Yeah, 8,000 here also. 8,000, and also this one. Now you see कि हमने 2 दफा disturbance की है. If this was the first disturbance, let me take this whole thing. And let's go to here. Okay, so we have a demonstration right now. Right. So so this is a demonstration from an online available tool. Acha. My aim is to show the feedback versus feed forward against the disturbance. Right. अच्छा, so do you remember हम the first time हम जो थे we were here at this spot. uh, this is the time when our system was in feedback. Okay, and this is the time when our system is in feed forward. Okay, और जब हम feedback में थे, and this is also corresponding to the around 12,000 something, ये भी हमारा feedback का है, ठीक है, एरिया, और यहाँ पे हम थे feed forward में. Okay, this one, and this corresponds to this one, and the same corresponds to this. ये जो peak है, this switch, अच्छा ये अगर हम गौर से देखें तो we have to ignore this point. This point is basically when we change our system from feedback to feed forward. यहाँ से onwards हमारे पास है feed forward. Okay, is it clear to all? या ये समझ में आ रहा है आपको? What I am showing you is a system, a plant. ये कोई सिस्टम है जिसमें हम बेसिकली कर क्या रहे हैं, वी आर द objective of this system is to control the level of a tank. ठीक है, अच्छा, and there is a disturbance here, और जो disturbance है वो है F out. Flow out जो है, flow out is a disturbance, right? और इसको हम करते क्या हैं, जो डिस्टर्बेंस है इसको हमने वी अप्लाई द डिस्टर्बेंस इन फीडबैक एंड फीड फॉरवर्ड. तो एक दफ़ा तो डिस्टर्बेंस जो आपके पास आई है, द फर्स्ट केस नंबर ए, केस नंबर 1, केस 1 में हमारे पास क्या है, कंट्रोलर इज फीडबैक, और जो डिस्टर्बेंस है दी it moves from 2 to 3, right? And then we also have a case number 2, I'm writing below, जिसमें हमारे पास feed forward control भी है, और जो disturbance है वो again 2 से लेके 3 तक जाती है, right? So in the first case, yellow will work here. In the first case, when we have this disturbance, this is the disturbance during feedback control. So feedback control में जब आपके पास से disturbance आई है, this corresponds to a change into, this corresponds to a change in the output y, ठीक है, और कंट्रोलर पे उसको वापस लेके आता है अपनी जगह पे. So we see some change. So what we observe here is a deviation. Disturbance की वजह से we see, due to we see change, we have a change in y due to disturbance. Okay, is it clear to all? ये बात. Now in the second thing, let's take a light blue here. अच्छा, now focus on this thing. अच्छा, मैं फिर वापस अपने सिस्टम पे लाऊं. Now there is a switch between, जब आप स्विच करेंगे फीडबैक से फीड फॉरवर्ड में, तो there is a little change here, और उसकी वजह से हमारे पास जो नया सेट पॉइंट है, this is a new set point. This is a set point, new set point when we have the feed forward control. ठीक है, कंट्रोलर. Okay. So assume पहले हमारे पास ये था, second time हमारे पास जो है disturbance set point is this one. Now again, when we have the second the disturbance during feed forward control, जब feed forward control में हमारे पास disturbance है, so we see, वापस हम correspondingly जाके देखें तो we see we have no change in y. So you see the difference between these two. Feed forward में benefit क्या हुआ, क्योंकि feed forward में we are measuring the disturbance. So this according to the disturbance आपके पास कोई the feed forward is able to take appropriate action. और वो appropriate action किस तरह से था, गौर से देखें तो इसने फौरन ही जो इनलेट है इसको चेंज किया, जो कंट्रोल एक्शन है उसको appropriately चेंज किया, ठीक है. So what we see here is a change in the control action. हम एक कंट्रोल एक्शन में चेंज देख रहे हैं, जबकि y में कोई चेंज नहीं है. While in the feedback case, we observe a change here in the output, as well as we see a change here in the control action. Okay, now जी, who is with me? Please raise your hands. अगर कोई आपको बात समझ में आ गई है तो please raise your hands. Please raise your hands if you understand what I'm telling you right now. Ali Irtiza.
जी सर.
बात समझ में आ गई आपके? Anas.
यस सर.
ओके, अच्छा, आप लोगों को एक असाइनमेंट मैंने दिया हुआ है. इन दैट असाइनमेंट राइट नाउ यू आर वर्किंग फॉर, जिसको मैंने अब एक्सटेंड भी किया है. एंड दिस इज बाय द वे, ये बहुत मुश्किल चीज़ नहीं है. इफ़ यू डू इट इन स्टेप बाय स्टेप यू कैन डेवलप योर ओन वेरी गुड सिमुलेटर, एंड in the field it is required. Or not only this does not only limit to your process control. So आपको पहला जो assignment दिया है वो about this है. Assignment number 2 जो है, it talks about how to implement this system, जिसमें inputs हैं, outputs हैं, and we have equations inside. We have inputs, we have outputs, and we have equations relating them. उसके बाद जो बाहर कंट्रोलर डिज़ाइन करना है, लगाना है, that will be the next assignments. But first, right now you are focusing on this implementing of this thing. ठीक है? Okay. अच्छा, अब ये होगा कैसे ये सारा काम? For sure, what we need here is अच्छा, I just skip this feed forward control. मैं इसके अलावा आपको एक दो और भी एग्जांपल्स दिखाना चाहता हूँ, but I will keep it for the next time. You can download these examples. मैं इसका लिंक आप लोगों से शेयर कर लूँगा. Now, so what are the benefits of feed forward control? हमने क्या देखा कि it was able to take the actions. So what we have seen here कि एक advantage ये है कि जो corrective action है, corrective action का मतलब कौन सा action है? Control signal. What we have seen here is कि जो corrective action है, it was taken by the feed forward controller, right? So corrective action is taken, control signal by feed forward controller, and before this process was upset. So no, of course there is a limit to this, but there is no upset in the output or the process. Okay. and theoretically capable of perfect control. Perfect control means we see no change in the level of tank, for example. Okay, and this does not affect the system stability. Very good. So these are the three advantages, but there are some issues. Let's see what are those issues. Disadvantages, सबसे पहली क्या चीज़ है कि whatever the disturbance is, जो भी सिस्टम को अफेक्ट करेंगे वो सारी की सारी मेजरेबल होनी चाहिए. For example, the capital, the cost, operating cost, and there are so many disturbances. वो सब measurable होनी चाहिए. This is one. Second is it requires more knowledge of the process to be controlled. यानी feedback control में तो हम एक simplified या less accurate model से काम चला सकते हैं. But in feed-forward control, we need good models. We need good process models. The third point is ideally controllers that result in perfect control may be physically unrealizable. क्योंकि आप एक एक्शन जो है वो देख रहे हैं, it is not realizable. We will see what does it mean when we revise the basic theory about the mathematical way of treating this. जो practical way है, this is using the lead lag controllers, lead lag units. They will come next. So इसकी practical जो है प्रैक्टिकली हम इसको जो यूज़ करते हैं वो एक अप्रॉक्सीमेट सोल्यूशन के थ्रू करते हैं. देयर इज एन अप्रॉक्सीमेट solution to this which is called lead lag controllers or units. ठीक है. And the third point is about using both feed forward control को भी आप यूज़ करें along with the feedback control. इसका एडवांटेज क्या है? फीड फॉरवर्ड कंट्रोल जो है वो फीड फॉरवर्ड कंट्रोल जो है वो डिस्टर्बेंसेस डीवी के अंदर जितनी भी वेरिएशंस हैं उन सबको देखेगा, और फीडबैक कंट्रोल जो है वो आपकी फॉर एग्जांपल मॉडलिंग एरर्स हो गए या वो तमाम डिस्टर्बेंसेस जो आप मेजर नहीं कर पाए उन सबको भी वो कैटर कर सकता है. ठीक है. सो दिस वाज आवर एग्जांपल. हिस्टोरिकली सबसे पहले 1925 में 3 एलिमेंट बॉयलर सिस्टम में ये कंट्रोल टेक्निक यूज़ की गई. 60s में फीड फॉरवर्ड कंट्रोल अप्लाई टू दी अदर प्रोसेसेस. नाउ लेट्स टेक डिज़ाइन. अब इसमें जो आपने इसके बैकग्राउंड में जो इक्वेशंस डिज़ाइन इक्वेशंस ऐड करनी है. नाउ द सेकंड इज जो असाइनमेंट हमारे पास नंबर मैं यहीं पे लिख देता हूँ. असाइनमेंट नंबर 3 विल बी रिलेटेड टू design equations of controllers, right? ठीक है. We saw equations for the ये जो पहली आपको लोगों को equations दी हैं, they are equations for the system. अब हम design equations for the controller की बात करेंगे. When we talk about the controller, इसमें जो main elements हमें चाहिए वो क्या हैं? If we recall, for the controller we have to work on the whole system. अगर ये controller है तो controllers को जो आपने inputs देनी है और outputs देनी है, there might be the disturbance input, there will be some output of the control, and then we might have some kind of error or the measurements of the y measurements. ठीक है. और इसके अलावा कंट्रोलर को और क्या इनपुट चाहिए होती है? मेजर्ड है, ये एरर हो सकता है, और डिस्टर्बेंस वेरिएबल है, यू है. व्हाट आई एम मिसिंग वन थिंग. व्हाट एल्स डू वी नीड इन द कंट्रोलर्स? एनीवन कैन टेल मी? एक चीज मैं मिस कर रहा हूँ, एक इंपॉर्टेंट वेरिएबल जो कंट्रोलर को जरूरत होती है जिसकी. व्हाट इज दैट वन? If we draw it again, it's basically coming maybe from here, set point. Okay, so set point in terms of the error will come here. Yeah, आप इसको directly भी कह सकते हैं कि we have to provide the set point to the controller as well. Set points. ठीक है. So अब इस एक एग्जांपल को देखते हैं. लेट्स से दिस इज अ सिस्टम ए. दिस इज अ हीट एक्सचेंजर सिस्टम. हीट एक्सचेंजर में वी हैव different variables. Let's see के कौन कौन से variables in W. We have a W here. W क्या है? It is the liquid flow rate. This is the liquid flow rate at temperature T1. इसका टेम्परेचर इनलेट लिक्विड टेम्परेचर T1 है और फ्लो रेट जो है वो W है, राइट. सो वी हैव अ टेम्परेचर, वी हैव अ फ्लो रेट of this one. What next? We have WS. WS is the steam flow rate, or we have an exit liquid temperature here, or W is the liquid flow rate for that one. इसका control objective क्या है? We have to maintain this the exit temperature T2, this T2 at the desired value or the set point. So what we need is a set point for settled for the exit temperature T2 despite variations in the inlet flow rate. So W आपके पास vary करेगा, so this is a variation and we need to do this by manipulating WS. और ये WS को हम manipulate करेंगे. How we are able to manipulate the WS? By using this control valve. So इसका मतलब है कि controller जो है it will be connected to this control valve, right? Control valve को वो control करेगा and ये जो controller बनाया it is basically this one, right? Feedback control scheme में क्या होगा? We will be measuring the output और यहाँ पे जो output है it is T2. यहाँ पर देखें तो output आपके पास है this one. So this is your output. This output should be measured and we provide this output to the controller. Okay, so T2, we will measure T2 and then we compare the T2 with the set point. So this will generate the error. Okay, so यहाँ पे आपको set point भी देना होगा इस controller को. Set point और यहाँ से आपके पास T2 आएगा. Set point is called T set SP. Okay, and then we need to adjust WS और WS को आप कैसे adjust करेंगे? WS is this one. ठीक है, this is WS और इस WS को जो adjust करेगा वो आपके पास ये control valve करना होगा. It's very simple. ये आपके पास है feedback control scheme. Okay, so I would like to share one question from here. For example, यहाँ पे आपके पास हो सकता है कि मैं आपको ये question दूँ and ask you, tell me about the feedback control scheme. What will you measure and what will you control? Both, number one for feedback control, number two to implement the feedforward control. Okay, so there is a question here that can be we are actually answering. The second is feedforward control. अच्छा, फीड फॉरवर्ड कंट्रोल में क्या हमने देखा था? फीड फॉरवर्ड कंट्रोल में हमने देखा था कि हम आउटपुट को मेजर नहीं कर सकते. दिस इज आउटपुट वाई, इसको हम मेजर नहीं कर सकते हैं, बल्कि हम डिस्टर्बेंस को करेंगे. तो डिस्टर्बेंस क्या है हमारे पास? डिस्टर्बेंस है आपके पास इसके अंदर वेरिएशन. सो वी नीड टू मेजर द W. W इज व्हाट? नोट इट डाउन. W इज द इनलेट flow rate and this is not in our control. It varies and it behaves as a disturbance to our system. Okay, so that's why जो हम basically what we are measuring is we in feed forward we measure DV, disturbance variables, which is W here, or of course we will adjust WS. For sure we need the set point and in turn we are actually controlling again the y. ठीक है? So is everything clear regarding in feedback control हमारे पास कौन कौन से variables होंगे जिनको हमने measure करना होगा. So what we are doing here is we measure y and control signal or adjust control. um, Let me make very specific terminology here. Okay, so in feedback control we measure the output y and we manipulate the manipulated variable, of course, which is ws, and this actually controls the output y. Okay, here we measure um, disturbance variable dv, which is w. We manipulate again ws, and we actually control y. Okay, so this is feedback control and this is feed forward control, right? Is it clear to all? So this is a one illustration for the feedback control. Feedback control में देखें तो what we have added here is we have a measurement from here. Can I put a highlighter here? Yes. So we have a transmitter. This transmitter is sending signal to the feedback controller. Feedback controller has the set point here. और ये जो feedback controller है, this is actually sending a signal to the control valve, and this control valve is manipulating the WS variable. Now in the feed forward controller, feed forward controller needs also this the set point, or it is now measuring the disturbance. Okay, and the temperature as well. These are the two things, but it is not measuring anything from T2. Okay, so disturbance is being measured क्योंकि इसमें दो variables हैं, but nothing is coming from output. Okay, so this is the output, and in feed forward we are not controlling it, we are not measuring it. Here nothing is going from this side. Okay, so nothing from here. This is the disturbance dv, this is the disturbance dv. ये एक से ज़्यादा भी variables हो सकते हैं, and we have y here, the output. Okay, so the design procedure will go like this. In the design procedure of the feed forward control, we discuss के हमें जो process model है वो बेहतर से बेहतर होना चाहिए. So we recall that the feed forward control requires some good knowledge about the process model. क्योंकि disturbance है तो how the material and energy balance is acting, उसके transfer functions क्या हैं. So this is the first thing that we must know. Then we have a procedure here, design procedure. इस design procedure में हम क्या करेंगे? We will actually, design procedure is nothing else but it's manipulation of or rearrangement of the equations. Okay, process equations. Okay, वहाँ से हमारे पास कुछ control equations सामने आ जाएंगे. So here we use some, here we will use material and energy balances written in the SS conditions. What is SS? Can anybody tell me? SS is, I hope nobody is sleeping. What is SS here? Hmm?
Steady state, sir.
Very good. Steady state, very good. So steady state conditions, example, doesn't matter हम tank level controller लें या फिर heat exchanger लें, we are focusing on the procedure right now. Or the thing is, we will focus on the steady state energy balance. Or so heat transfer from the steam is represented by WS delta HB. We are not going to in the detail of the कि ये किस तरह से है. Heat added to the process steam, this is the balance, latent heat of vaporization, specific heat. Soon you will see कि ये सारे constant जो हैं, they will be clubbed into one variable. Rearrange करते हैं और अब हम focus करेंगे. अच्छा, by the way, this rearrangement means we again focus and rearrange the things so that we will have the set points, disturbance variables, the set points, and the measured variables, CVs, ये सब जो हैं input और output पे आ जाएं. ठीक है. So WS it was what? WS was our manipulated variable, okay, MV. So we see कि MV को हम, क्योंकि ये हमारे पास जो है WS is the one जो कि reflect करता है कि this is what we need to manipulate or to control. First to control. Okay, ultimately this will cause the control in the, let's use the proper word, just use manipulate. Okay, this is the one that the controller has to manipulate for controller output or the manipulated variable. Okay, then इसमें we will together call this as a K here, and we will have something like this. WS equals to some constant times, this is another variable. This is T2 is the output Y, and T1 was our inlet. Replacing T2 by the set point, since T2 is not measured, क्योंकि हम बात कर रहे हैं feed forward की, तो feed forward में we have no measurement of let's say the output Y. So उसको output को Y को हम replace कर देते हैं Y set point से. Okay, so we replace this thing, and then equation number 5 now can be used in the feed forward control calculations of the digital controllers. It's very simple, straightforward. अब ये आपके पास control signal है, जो control signal है, it will be calculated like this. T1 और W क्या चीज़ हैं? Now who will tell me what is T1 and W? By the way, this K will be calculated by, these are like constants or system parameters that should be given to us. This is a constant, and T set point, this is the temperature set point. Okay, कोई measurement की ज़रूरत नहीं है. What about W and T1? Going back here, W और T1 क्या चीज़ हैं? Coming back here, we were measuring W. इस स्कीम में अगर हम देखें तो W और T1 were the disturbance variables, जिसको अब हम measure कर रहे हैं. We have a flow transmitter, we have a temperature transmitter. So both are available for the feed forward control. So इसका मतलब है कि T1 and W1 are the what? DVs, means the disturbance variables. और ये हमारे पास मौजूद है. ठीक है. So in this demonstration, इसके अंदर जो equation थी feed forward की, it was similar to this one. Allow me to write It was doing something like this. WS was being calculated with a constant K, W, T, SP, not exactly applicable to this, just to show you, okay, this was the simple calculation or equation that was the feedback controller calculating and bringing out here. Okay, so we have just found one feedback calculations done at the steady state. So equation 5 can be used in the feed forward control calculations and implement in digital computer. By the way, we can use K as an adjustable parameter. ठीक है, अच्छा फायदा क्या है इस डिजाइन प्रोसीजर का? You just have seen it is very simple and controls is stable and self-regulating. Okay, from here onwards, we will start. Next time we will study the second example. I will upload up till here. Okay, thank you very much. अगर कोई question है तो kindly please let me know. And I encourage you to complete your designs on the LabVIEW, so that you can do this dynamically on your system. Any questions? Let me take the snap of the attendance. Okay. Okay, if there is no questions, then I'm closing this.